Okay, we're going to be looking at Riemann sums applied to abstract data, and it's actually not that difficult. So I know that it has this kind of integral symbol right here, so don't let that scare you. All right, it's the same thing as me saying I want the sum of the values, all right, in this case from 0 to 6, of some f of x sub I delta x. All right, so it's the same thing. All right, what we're going to do is we're going to, in this first case, look at a left sum. So here is a left sum with 3 subintervals. So the first thing I'm going to do is I'm going to calculate my delta x. And I do that by taking my final minus my initial value. So my final x value here is 6. And my initial value is this one right here, which is 0. And I'm going to divide that by 3 because that's how many subintervals, in this case, how many rectangles that I want to create. So 6 divided by 3 being 2. So my delta x is 2. So I am going to have a rectangle basically every 2 units. So let's take a look here. 0 to 2, that's one rectangle. 2 to 4 is another rectangle. And 4 to 6 is another rectangle. And so if I'm looking at the left value, I'm going to be looking at the leftmost value in that interval. So here is the leftmost value, 7.6 from 0 to 2. From 2 to 4, my leftmost value is this right here, 6.4. And from 4 to 6, my leftmost value is 4.5. So what I'm going to do, since everything is getting multiplied by delta x, I'm going to multiply all of this. Okay, so let's write this out using this definite integral that they give us. All right, let's write it out. All right, to say, well, 2, since everything's being multiplied by 2, times the sum of those f of x or the y values. 7.6 plus 6.4 plus 4.5. Okay, we add all of that up, multiply it all by 2, and on our calculator we'll get something like this, 37. Okay, now that's not too difficult. Let's take a look at the next one. Okay, the next one says, using a right sum with 3 intervals, find the area under the curve from 0 to 6. So again, let me pick a different color. 0 to 6, we have the same intervals, okay? And I can write out the calculation for you if you need to see it one more time. Delta x equals 6 minus 0 divided by 3. So our delta x is 2 units. And that's why I wrote those out. But in this case, we are using the right sum. The right sum. All right? So we're going to be using the rightmost value. So from 0 to 2, the value on the right of the rectangle is 6.4. From 2 to 4, the value on the right of the rectangle is 4.5. And from 4 to 6, the value on the right of the rectangle is 3.4. So we are going to, again, write out the same kind of definite integral notation. Again, you can write it as a summation if you wish, but we're going to factor out that 2 because everything gets multiplied by 2, and we just sum up the y values. 6.4 plus 4.5 plus 3.4. And when we do that on our calculator, or you might be able to do it in your head, we get something like this, 28.6. Okay, now we're going to take a look at one last example here, and that is the Mid Riemann sum. All right, the Mid Riemann sum. So let's see what that looks like. We've got a delta x here, and we're going to say, okay, well, what is this right here? This is 6, take away 0, because we have a final minus initial from 0 to 6, and then again they tell us 3 subintervals. So we divide by 3, so yet again we have 2 as our delta x value. Okay, so we're good here. We're going to draw out our subintervals, and let's say we use the color red. So 0 to 2 is one subinterval, 2 to 4 is another subinterval, and 4 to 6. That follows our delta x being 2. And we're going to use now the value in the middle of those numbers. So the middle number from 0 to 2 is 7. The mid number from 2 to 4 is this 5.6. and the mid number from 4 to 6 is 4.1. So again, we can factor out that 2 when we're doing our computation here, and we're going to get 2 times the sum of 7.0 plus 5.6 plus 4.1. All right, and when we do that on our calculator, possibly even in our heads, we get something like this: 33.4 units squared. So this is a little bit on how we can apply Riemann sums to abstract data, and hopefully it makes some sense to you. They're really nice examples. You may not see this in a lot of your online homework programs or anything like that, but it's important to note if you're taking, some big end of the year test, that gives college credit, for example. I'm not going to mention any names because it's copyrighted, but if you're taking some kind of test, they like to ask these type of questions, and they're kind of easy points to get if you know how to do them. And they ask these in their free response section. So I hope, as always, that this video was helpful, and remember, like and subscribe.